Yeah, good morning all of you. Under Signals and Systems subject, today we are going to discuss operations on signals. It is very important part because for a given signal, whether it is continuous time signal or a discrete time signal, we should be in a position to do several operations on the given signal. So, and these operations may be with respect to time axis or with respect to amplitude axis. So, these operations may be with respect to the independent variable time, and these operations may be with respect to the dependent variable amplitude, with respect to amplitude or with respect to time variable. Based on that, we have six types of operations we can perform it on the signals. That is, time shifting, time reversal and time scaling are the three operations with respect to time axis, and amplitude scaling, signal addition and signal multiplications are the operations that can be done with respect to the amplitude axis. We are going to see all these operations elaborately. First one, time shifting operation. Here, similarly, every operation can be defined for both continuous time and discrete time. So first let us start with continuous time. So if you take a continuous time signal x of t and the time shifted signal, if the signal x of t is shifted by an amount of tau in time domain on either side, then the time shifted signal, if you denote it as y of t equal to x of t minus tau, where tau is the shifting operator, y of t equal to x of t minus tau. Here, based on tau, we can tell whether it is left shifting or right shifting. Already I told you it is with respect to time axis. So shifting may be either right side or left side. So if tau is positive, it means this minus is preserved as it is. Then it is called right shifting of the signal, or x of t is, the given signal is delayed, it produces some delay. X of t exhibits delay. Similarly, if tau is negative, it means if tau is negative, minus of minus becomes plus. So t plus something, then it is called left shift. It is left shift, or it is also called as x of t advances. The signal is advanced by tau times. The signal is delayed by tau times. Okay? Like this, we can define the signal in continuous time. Same concept we can apply for discrete time also. There is no change. In discrete time, concept is same. Take a given signal x of n. So if the resultant shifted signal is y of n, then it is denoted as x of n minus k. K is the shifting operator here. If k is positive, means minus is preserved as it is, then it is right shift or delaying the signal. If k is negative, it means positive sign will come here. Then we can say that it is left shift or advancing the signal. Concept is same. That is called time shift. For doing the problems, what we do is, to do the time shifting, take the signal x of t. Time shifting means t is replaced by t minus tau. Tau will be given in the problem. T replaced by t minus tau. Then we get x of t minus tau. It may confuse you at this stage. While doing the problems, you can easily understand the importance of this. Time shifting means t is replaced with t minus tau. Then the resultant signal is x of t minus tau. For clear understanding, let us do some problems. Then your doubt may be cleared. Yeah, here it is one example for clear understanding of time shifting. It is a given signal x of t in the interval 0 to t. It is defined in the interval 0 to t with an amplitude of a. And if you want to find out, suppose x of t minus capital T or something. Suppose if t equal to 2, x of t minus 2. Then what is the meaning of it? X of t, for every value of time, 2 is added. 2 is added. Then adding the value, it shift to the right. So 0 plus 2, starting value will be 2. Next all values, last value is 6. 6 plus 2, 8. So as the limits of x of t are 0 to 6, then the limits of x of t minus 2 will be 2 to 8. Similarly, right shifting, x of t plus 2. X of t plus 2. Left shifting, here it means subtracting each time value of x of t by an amount of 2, then it will move to the left side. It means subtracting 0 minus 2, minus 2, 6 minus 2, 4. So the signal x of t plus 2 ranges from minus 4 to minus 2 to 4. Whereas the original signal ranges from 0 to 6. Like this we can easily understand the discrete time version also. Next, the second operation is time reversal. The name itself indicates reversal of a signal with respect to time, with respect to time axis. Suppose if we take a signal x of t, if it is reversed in time, then the resultant signal y of t is denoted as x of minus t. X of minus t. It means, what is the meaning of it? Here the time variable t is replaced with minus t. The time variable t in x of t is replaced with minus t. Then it is called time reversal. Time reversal. Here also same thing we can define it for discrete time. If a discrete time signal is x of n, then the time reversed signal y of n equal to x of minus n. Here also n is replaced with minus n. Same concept, notation is changed. We can see some examples for clear understanding of it. See here. Here a signal x1 of t is defined in the interval 1 to 3. 1 to 3. Time reversal means time axis is reversed. T replaced with minus t. Remember, t replaced with minus t. So x of t values 1 to 3 becomes negative. It means 1 becomes minus 1, 3 becomes minus 3. So the time reversed limits are minus 3 to minus 1. See, minus 3 to minus 1. Only time values are reversed. There is no change in the amplitude. That is very important. No change in amplitude. No change in amplitude. Only time values are reversed. Here it ranges from 1 to 3. So the time reversed one ranges from minus 3 to minus 1. Similarly, you can see a discrete time signal x of n, it ranges from 0 to 4. 0 to 4. Only time values are reversed. 0 becomes 0, 1 becomes minus 1, 2 becomes minus 2, 3 minus 3, 4 minus 4, but there is no change in the amplitude. Here At 1 the amplitude is 3, at minus 1 also amplitude is 3. It means at 0 no change, at 3 same amplitude, amplitude 3 only, not minus 3. Here at 2 amplitude is 2 only, not minus 2. Similarly here 1 only. So that is the resultant signal. That is the resultant signal. So the signal which exists from 0 to 4 is now exists from 0 to minus 4. That is the time reversed one in continuous time and discrete time. Very easy to understand this one. Next. Third operation with respect to time is time scaling. Here, scaling the signal with respect to time axis. Scaling means we can compress the signal with respect to time, we can expand the signal with respect to time, then that process is called time scaling. Try to understand the difference between scaling and shifting. Shifting means the given signal is shifted either to right or to left completely. Whereas scaling means either expansion of the signal or compression of the signal. Okay, I think the difference is very clear between shifting and scaling. So here also, in continuous time, let us take a signal x of t, then the scaled signal y of t is denoted as time scaling, no? So that's why the time variable is multiplied with a constant. Here A is the scaling factor here. Remember here, as it is time scaling, the signal is scaled with respect to time. So the time variable t is multiplied with a scaling factor A. Here, based on the A, we can tell whether it is expanded or compressed. If A is greater than 1, if A is greater than 1, here x of t is compressed. X of t is compressed with respect to time. Similarly, if A is less than 1, then x of t is expanded or stretched. It means in the time scaling, every value of time is divided by A. Every value of time is divided by A. We will see with examples. Similarly, we can define the same for a discrete time also. A discrete time signal x of n, then the time scaled signal y of n is denoted as x of an. Same, if A is greater than 1, it is compression. If A is less than 1, it is expansion. Here also, every value of time variable n is divided by A. Let us see some examples for clear understanding. Yeah, here, see, let us take a signal x of t which exists from minus 1 to 3. Minus 1 to 3. Here, you can easily find out the scaled version. Here, A equal to 2. A equal to 2. Then the given signal is y of t equal to x of 2t. X of 2t means it is a compression. Already I told you, here 2 is greater than 1. When A is greater than 1, it is a compression. It means every value of time every value of time is divided by the 2. So, what is the first value? Minus 1. Minus 1 divided by 2. Minus 0.5 is the starting value. Whereas here starting value is minus 1. Similarly, every value is divided by 2. Last value is 3. So, 3 divided by 2. It will become 1.5. So, the given signal x of t which is from minus 1 to 3 is now ranges to minus 0.5 to 1.5. So that's why it is compression. The signal is compressed. And here A is greater than 1. Similarly, you can go for x of t by 2. T by 2 means here x of 1 by 2t. Here A equal to 1. A equal to 1 by 2. So here A is less than 1. A equal to 1 by 2 means A is less than 1. It should be an expansion. It means what? How do we get expansion? So now every time value is divided by A. Here A equal to 1 by 2. Minus 1, so starting value, minus 1 divided by 1 by 2. It means minus 2. It will become minus 2. So the starting value of the expanded signal is minus 2. Similarly, the ending value is 3. 3 divided by 1 by 2. 3 divided by 1 by 2. Every value is divided by A, no? So it will become 6. So the last value is 6. So the original signal, which is from minus 1 to 3, is expanded to minus 2 to 6 with a value of A equal to 1 by 2. That is compression and expansion. Similarly, we can see the same concept in for discrete time also. It is very easy for you to understand in the same way. Thank you.